Okay, next question is question number 6. Figure 6.1 shows the structures of zinc sulfide and disulfur dichloride. Zinc sulfide has a structure similar to diamond. So diamond has a joint covalent structure. So it means zinc sulfide also has a joint covalent structure. And the disulfur dichloride, it has simple molecular structure. Okay, so A part 1, explain why zinc sulfide does not conduct electricity. So if you look into the diagram of the zinc sulfide, all the atoms are involved in bonding. So if all the atoms are involved in bonding, it means there are no free moving electrons that carry the electric charge to conduct electricity. Okay, part 2 is predict one other physical property of zinc sulfide. So another property that we can write here is it has a high melting point. Okay, next part B, why disulfur dichloride has a low melting point. Disulfur dichloride is a simple molecular structure, and simple molecular structure has low melting point. The reason is as they have weak intermolecular forces. Of attraction. Okay, next part C. Complete the figure 6.2 to show the dot and cross diagram for the electronic configuration of disulfur dichloride. So first we will take the values from the periodic table. Atomic number of sulfur is 16, means 2, 8, 6. So there are 6 electrons in the outermost shell. So out of 6, 2 electrons, because there are 6, it means it needs 2 more in order to complete its outermost shell. So out of 6, 2 electrons are involved in bonding, and the remaining 4 electrons are not involved in bonding. So if you look into the diagram, we have sulfur that is connected to 2 atoms. Each sulfur is connected to the 2 atoms. So 1 cross on each side. For both the sulfurs, 1 cross on each side. So for the second sulfur, I am using a dot to differentiate both the sulfurs, okay? And another dot. Okay, for the chlorine, we have 17 atomic number. So the configuration is 2, 8, 7. So chlorine needs only 1 electron. So out of 7, 1 electron will involve in bonding, and remaining 6 will not involve in bonding. So if 1 electron is involved in bonding, I am using dot for this chlorine and I am using cross for this chlorine. So far we have completed the sharing electron between the sulfur and the chlorine atom. Now we have to draw the electrons that is not involved in bonding. For the sulfur, we have 4 electrons. So I will put 4 crosses, 1, 2, 3, 4 for this sulfur. For the second sulfur, I use the dot. So I will put 2 dots like this. So if you count the electron, 1, 2, 3, 4, 5, 6, 7, 8. So it means now the total 8 electrons are there. Okay, for the chlorine, 6 electrons are not involved. So 6 cross for this chlorine and 6 dots for this chlorine. Now this is the complete diagram for the disulfur dichloride. Okay, next is disulfur dichloride react with water as shown. 13.5 gram of disulfur dichloride reacted with 8 gram of water. Show by calculation that water is in excess. Whenever examiner asks a concept, excess or a word limiting reactant, so always calculate the moles of each reactant. So we will first calculate the moles of S2Cl2. So the value of gram, the value is given in gram. It means we will apply the formula mass over molar mass, MR. So the mass is 13.5 and the MR of sulfur disulfur dichloride is, we will calculate the MR here. Sulfur is 32 into 2 plus chlorine is 35.5 into 2. So the answer is 135. So 13.5 divided by 135. So the answer is 0.100 mole. So this is the mole of disulfur dichloride. Now let's calculate the moles of water. For the water, it's also the value is given in mass. So we'll apply the same formula, mass over MR. Mass is 8 gram and the MR of water is 18. So I'm writing a direct value 18 for the water. Because oxygen is 16 and the hydrogen is 1. So 2 into 1 plus 16 is 18. So 8 divided by 18 is 0.44 mole. Okay, after doing this, we have to apply the mole ratio to prove that water is in excess. So mole ratio between both the reactants, so S2Cl2 ratio water. As per the balanced chemical equation, 1 S2Cl2 needed 3 water molecule. So 1 S2Cl2 needed 3 water molecules. So if I use this value of S2Cl2, so how much water molecules will be needed? So 0.100 is 2x. It means, to simplify this, 0.100 into 3 divided by 1, answer is 0.3. So we needed 0.3 mole of water, but in reality 0.44 mole of water is used. This is the bigger number, so it is proof that water is in excess. So we can write this statement, moles of water needed is 0.3 mole. So the mole that is used at 0.44, so it means water is in excess. Okay, next part, E. Sulfur dioxide is an air pollutant. Part 1. State one adverse effect of sulfur dioxide in the air. So the adverse effect of the sulfur dioxide is acid rain. Okay, part 2. Describe 2 ways of reducing the emission of sulfur dioxide in the air. So to remove the sulfur dioxide, we can use low sulfur fuels, and for the second we can use flue gas desulfurization. This is basically a method in which we react sulfur dioxide with calcium oxide to neutralize it to make a slag as we did in the iron industry. So this is all about question number 6.